Physics 2, Lab 4, Magnetic Field of a Bar Magnet by Jackson Banger. So some intro. We're trying to better understand magnetic fields through visual representation and understand more about some of the laws for magnetic fields. Here we have some of the common formulas we're going to use. So we have the formulas for a dipole. These are going to be really crucial for calculating mu. And we can also use these to approximate values at any location. Um, so some of the setup, we used a magnetometer and ruler sticks to measure distance of how far we are away from a magnet. And we can compare this to how the computational model works with the equations. And some experimental data here. We plugged in all of the data that we got in our lab that were measured with the magnetometer, and this created a graph. And so we can use the slope of that graph and the y-intercept to calculate some things. So the calculations we do here are some of the formulas given in the lab. So we first solve for mu using the formulas that we were given. And then on the right here, we use the slope of the graph and the y-intercept to solve for k. And then we plug k in to our equation on the left. And we also use the slope. R basically goes to 0, and we're left with this as our answer from mu. So some of our observations, we noticed that the first and fourth should be the correct ones because when we take the magnetometer far away, Bx was close to 0, and as it increased as we brought it closer to the magnet. So in our coding here, we defined a function for the magnetic dipole, and then we created a bunch of arrows to visualize this using the distances that we have. And then we used the locations of 6 or 7 points and created the arrows here as well for visualizing the field. And then these are some more measurements that we took, and this is for calculating the vector for the off-axis angles. And then these are our outputs, so we can see that the different colors will show the off-axis and the perpendicular fields. Also, all of those are given here. And then some of our results, we found that the computational model and the experimental model are quite different in the BNet. This could be for a lot of reasons. We could have with your measurements and a couple other things. And despite some minor discrepancies, they sort of align. There could be a lot of different experimental factors that mess this up. And then in our discussion, if you hadn't orientated your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field, how would your results have changed? Well, Bx would have been off by an interference by Earth's magnetic field. This would all be to the same, like, similar magnitude. Like, it would be off by the same magnitude. And then if they were two identical magnets together end to end and run the experiment again, all measurements would be off by a different factor. It would just change some of the measurements, because it's like if you're basically doubling the magnitude of the forces that the magnet is creating.